Good morning, guys. I hope you and your family are doing well. This is the second week of online learning, and what we're going to talk today is multiply polynomial expressions. So last time in the previous lecture, we learned how to adapt, how to subtract the polynomial expressions by combining like terms. We also learned the definition of polynomial. We learn how to identify the leading coefficient and the degree of a polynomial function. So in this lesson we are going to learn how to multiply polynomial expressions, and there are two main methods we can use to multiply polynomial expression. One method is distributive property. The other method, which in my experience look a little bit more simple for students, is the box method. We have seen these methods already, and you can think of multiply polynomial expressions as a review, okay, of something we have done already. So so I'm going to show you some examples. My suggestion is that when I write down the problem, you first try to work these problems on your own. So you stop the video, you work the problems, and then you check your understanding with what I'm going to show you. So let's start with something I would say basic, which is this one: multiply two linear expressions. So one is 2n plus 2, and we want to multiply this by 6n plus 1. So you should first try to do this on your own and then check with me. Alright, so one strategy is to use distributive property, which means since we have two terms by two terms, the final expression is going to be made up by 4 terms. So we need to make sure we multiply all possible combinations. So 2n times 6n, which is 12n squared, because n times n is n squared. 2n you multiply by 1, we end up with 2n, and then we have 2 times 6n, which is 12n, and then last term is 2 times 1, which is equal to 2. And at this point you can just combine like terms, and the only like terms are 2n and 12n, so we end up with 12n squared plus 14n plus 2. So here we have a polynomial expression whose degree, which is the highest exponent, is equal to 2, and whose leading coefficient, so I'm going to abbreviate as LC, is the number in front of the highest degree term, which is equal to 12. Okay, so let me show you a second example, and I'm going to use a different method. Let's assume we want to multiply p minus 2 by 6p plus 2. So again, try to do this by yourself first and then check with me. So here is a different strategy you can use, which is the box method. We have already seen this in classes, so it should not be new to you. But we make a 2 by 2 box because we are multiplying 2 terms by 2 terms. So we write one polynomial expression at the top of this box, for example p minus 2, and the other one on the side, so 6p and 2. And then we multiply all possible combinations. 6p times p is 6p squared. 6p times negative 2 is negative 12p. 2 times p is going to give me 2p, and 2 times negative 2 is going to give me negative 4. Notice that the only terms we can combine are the one in the main diagonal, so 2p and negative 12p. 6p squared is by itself, so we need to keep it, so we get the 6p squared. 2p minus 12p is going to add up to negative 10p, so we can combine these two. You always add, okay, combining means add like terms, so negative 10p, and then the negative 4 is by itself, so it's going to stay. So we have a polynomial expression of degree 2 with a leading coefficient which is equal to 6. Here a problem a little bit more challenging. We are going to multiply a 3 terms polynomial expression by a trinomial, so 3 terms means trinomial, so 2 trinomials, that's what we're going to do. So we have a 6n squared minus 6n minus 5. We're going to multiply this by 7n squared plus 6n minus 5. Alright, so we can use distributive property. We're going to end up with 9 terms because we're going to multiply a 3 terms polynomial, so a trinomial, by another trinomial. So we're going to end up with 9 terms. But we can, use the box method and make a 3 by 3 box. And then we write one polynomial expression at the top and one on the side. So 6n squared minus 6n minus 5. And then on the side we have a 7n squared plus 6n and then minus 5. Alright, so let's see what we get from here. 7n squared times 6n squared will multiply to 42n to the power of 4. 7n squared times negative 6 is going to give me negative 42, and then n squared times n is n to the power of 3. And 7n squared times negative 5 is negative 35n squared. And then we need to multiply by 6n, so 6n times 6n squared is 36. Okay, let me fix this, so we have 36n cube, and then 6n times negative 6n is negative 36n squared, and 6n times negative 5 is negative 30n, and then negative 5 times 6 is negative 30n squared, negative 5 times negative 6n is 30n, and negative 5 times negative 5 is positive 25. Now 42n squared is by itself, so we're gonna keep it. Okay, so this is by itself, 42n to the power of 4, and then what we notice is that this negative 42 and this 36 can be combined together. Okay, notice also how 30n and negative 30n cancel out, and then if you look at the main diagonal, all of these terms are like terms because they all have an n square with them. And then 25 is also by itself, right? Alright, so what we get? 42n to the power of 4 is by itself. 36n cubed minus 42 means negative 6n cubed. And then negative 30, negative 36, negative 35. Remember, we need to adapt these three terms. So if you adapt negative 30 plus negative 36 plus negative 35, so you end up with a negative 101, and then we have an n squared next to it, so negative 101 n squared. The 30n simplify with the negative 30n, and then 25 is by itself. So we end up with a polynomial expression of degree 4 because we are multiplying two trinomial with with degree 2 and then when we multiply we know that we need to adapt the exponents, right? So if we multiply polynomial expression of degree 2 with another of degree 2, we're going to get a polynomial expression of degree 4. So we have a degree 4 with a leading coefficient which is 42. So I hope this is clear to you. So let me show you a few more examples. Here is another one. 7r squared minus 6r minus 6. We want to multiply this by 2r minus 4. Okay, so we are going to make, so this polynomial expression is a trinomial, so it's made up by 3 terms. This polynomial expression is a binomial, so it's made up by 2 terms. So we expect to get a polynomial expression made up by 6 terms. Eventually we can simplify, we can combine some of them, and the polynomial expression we're going to obtain is going to be of degree 3 because this first trinomial is a degree 2, the second binomial is a degree 1, so when we multiply, we need to adopt exponent. Degree 2 plus degree 1 is going to make a degree 3. So let's make a 3 by 2 box. So 3 terms at the top, 2 on the sides. So we get a 7r squared minus 6r minus 6, and here we write 2r minus 4. And then when we multiply, so 2r times 7r is 14r cubed, 2r times negative 6r is negative 12r squared, and 2r times negative 6 is negative 12r. And negative 4 times 7 is negative 28r squared, and negative 4 times negative 6 is positive 24r, and negative 4 times negative 6 is positive 24. Alright, so we end up with what? Well, we have a 14r cubed, which is by itself, we cannot combine with anything. And then these two elements, these two terms can be combined. Negative 28 plus negative 12 is going to make a negative 40r squared, and then negative 12r and 24r is equal to 12, positive 12r, and then the 24 it stays by itself, so plus 24. So we get a polynomial expression of degree 3 with a leading coefficient which is 14. Alright, so let's take a look at a more interesting problem, and let's see if you can first answer this by yourself. Okay, so the question is, what is the area of a square whose perimeter is P equal to 16x plus 28. Okay, so again, I suggest that before you look at this process, how to solve this problem, you try on your own. You may sketch a picture, okay, so draw a picture, try and then try to solve it, and then check again with me, okay, so you should stop the video and work this problem. Alright, so at this point I hope you try to work this problem on your own, and now we're gonna do this together. So we have a square, and we know the perimeter of this square. So the perimeter is this one, is 16x plus 28. By being a square means that all the sides are congruent, so they have the same length. So this is L, all of these are going to be the same length. And what we know is that the perimeter is 16x plus 28, which means that the sum, by definition, the sum of the side length of this square must be equal to 16x plus 28. So if I add these four sides, I get 4L, and I know that this must be equal to 16x plus 28. I want to find the area. The area of a square is side times side times self, so L squared. And so once I find L, I can just square that number, and I'm done. Okay? So let's find L from here. We can divide both sides by 4. We don't know x, so we're going to obtain an expression with x. And we end up with L. So if I divide 16x plus 28, what we have is 4x plus 28 over 4, which is equal to 7. Now that we found L, we can compute the area by multiplying L by itself. So remember, the area is L squared, which means 4x plus 7 squared. Now if you remember, we can use the square wave binomial formula, or we can multiply 4x plus 7 times 4x plus 7. For the ones of you who want to use the formula, I remind you that a plus b squared is equal to a squared plus 2ab plus b squared. And then if you want to use the formula, then you should make a 2 by 2 box. And what we have is 4x plus 7, 4x plus 7, and we multiply all of those terms. So 4x times 4x is 16x squared. 4x times 7 is going to give me 28x. And then 7 times 4x is the same, is 28x, and 7 times 7 is 49. We can only combine the like terms in the main diagonal, so we end up with 16x squared plus 56, 28 and 28, so 56x and then plus 49. So this is the area of the square, which depends, it's a function of x, okay? And what we get is a polynomial function, so the area is a polynomial function of degree 2 and leading coefficient, which is 16. That's the degree, and the number in front of the highest degree term, I remind you, is the leading coefficient, okay? Okay, so there is one last problem I would like to show you. Okay, so here is the problem. What is the area? No, I'm sorry. Let me draw a picture first, okay? Alright, so let's draw a picture. And imagine you have a rectangular room. Okay, so that's just a rectangular room. And you have the original dimension of this rectangular room that are 6 feet by 10 feet. 6 feet by 10 feet. Okay? And what you want to do is you want to extend this room. Okay? So if you extend this room, extend the room by x plus 1 feet. Okay, so question number 1. What's the new area? And number 2, how many square feet of area do you add once you do the extension? Okay, so try to solve this problem on your own and then again check with me. Okay, so I assume that you already tried to work this problem. Let's see if we can answer these two questions. Alright, so the first thing we want to do is probably find the original area. We know that this is a 6 by 10 feet room, so the area, the original area, since it's a rectangle, is length times width, so the original area is 60 square feet. Okay, so that's the original area. Now, but the question is, what's the new area once we do the extension? So we want to extend this by x plus 1 feet. Now, in order to understand what to do, imagine this was a number, okay? Imagine this was, so an example here, imagine this was 2 feet, okay? What would you do? Well, this 6 here will become 8 feet, because you are extending by 2 means you are adding 2 feet to 6, and this 10 will become 12 feet, because you're going to add these 2 feet. The fact is we don't know what's x, so what we need to do is add x plus 1 to 6 and add x plus 1 to 10. So we're going to end up with a new room with new dimensions, and those dimensions are a function of x. So what's a 6 plus x plus 1? Well, we can combine 6 for plus 1, right? They are like terms. We can drop those parentheses, right? Because it's like we have a hidden 1 outside the parentheses, and by distributing this 1, you still get x plus 1 without parentheses. So we end up with 7, because 6 plus 1 is 7, and then x, we can do nothing with that, so we keep it. And what's 10 plus x plus 1? Well, we can combine 10 with 1 to end up with 11 plus x. Alright, so at this point, we can find the new dimensions, and well, we found the new dimension, we can find the new area, so we can answer number 1. So the new area is length times width, which is 7 plus x multiplied by 11 plus x. And what we end up with is, so we can just use distributive property, 77 plus 7x plus 11x, and then 77, 7x, 11x, and then we still have x squared. Okay, so we can combine the terms. So this is equal to 77 plus 18x plus x squared. So this expression is the new area. You don't need to write the polynomial expression necessarily starting from the highest degree term, okay? We usually write starting from x squared, then x, and then 77, but you can also start from the constant term 77. So that's a new area, which means we answer question number 1. The second question is number 2, which is how many square feet of area do you add, right? So we want to compare this with the original area, which was 60. So how many square feet do we add? Well, what we need to do is the difference between the new area minus the original area. That's how much we add, right? So let's subtract these two amounts. So what we have is x squared plus 18x plus 77, and we want to subtract the original area, which is 60, and the only terms we can combine are 77 with 60, so we end up with x squared plus 18x minus 17. So this last expression represents the amount of square feet that we added by extending this room by x plus 1 feet. Okay? So I hope that this concept is clear. So remember, what we did is multiply polynomial expression. So I show you some examples with using distributive property, using the box method, and I show you also some application of multiply polynomial expression. If you have any question, please contact me. You can use Schoology, or you can use my Gmail to send me an email and ask me any question, so any help you need. Okay, so I'm going also to assign a homework on Alex, and make sure you complete which is based on this concept, and make sure you complete this homework by Monday. Okay, so I hope everything is fine, and I'll talk to you later. Thank you.